Good morning, 7th grade. It is Wednesday, April 15th, and I hope that you and your family are doing well. Today, we are going to continue our exploration of compound probability. This time, we're going to look at an example where multiple things are happening, but it's multiple very different things, as opposed to just the same thing happening over and over again. So, the example we're going to use is at the St. Ignatius Carnival. A game is played where three things happen. First, a standard American quarter is flipped. Then, a 12-sided die is rolled. And finally, a spinner with 6 equally sized sections, colored red, blue, black, green, white, and yellow, is spun. So in order to play the game, you have to do 3 things in this order. Flip the coin, roll the die, spin the spinner. We're going to look at what the probabilities are of certain results happening for those 3 activities. So let's look at what up here is listed as number 9. And in number 9, in order to win, we need to flip a heads, then roll a prime number on the 12-sided die, and then spin black on the spinner. So the first thing we need to do is break down the probability of each of those things happening individually. Let's look first at the probability of flipping a heads. How many total possible results are there if you flip a coin? Well, there's 2, heads and tails. How many of those results give us what we want? How many of those give us heads? That's 1. So the probability of flipping heads, our first activity, is 1/2. Put in a multiplication sign. What's the probability of rolling a prime number on a 12-sided die? What are the prime numbers between 1 and 12? Well, we don't count 1. 2 is prime. 3 is prime. 4 isn't. 5 is prime. 6 is not. 7 is prime. 8, 9, 10 aren't, and 11 is prime, 12 is not. So, between the numbers 1 and 12, there are 5 prime numbers. So our denominator for this second thing is going to be 12, because there are 12 possible things you can roll on a 12-sided die. Of those 12, 5 of them meet our requirement and are prime. Put in our multiplication symbol. Finally, we want to spin black on the spinner. Well, first off, how many different possible results are there on the spinner? There are 6. Red, blue, black, green, white, and yellow. So we put a 6 on the bottom. And of those, how many meet our requirement? How many are black? Only 1 of them. Okay, now we've got our 3 individual probabilities, and we're going to combine them by multiplying. We should take a step before we do that to see if we can simplify any of these. We can't, so we can just go ahead and get to the multiplication. Across the top, we've got 1 times 5 times 1. 1 times 5 times 1 is, of course, 5. And across the bottom, we have 2 times 12 times 6. Well, 2 times 6 is 12. Multiply that by 12, 12 times 12, and you have 144. So the probability of getting the exact sequence, heads, prime number, black, is 5 out of 144. Okay, let's look at number 10. Very similar setup, using the same materials, and we're going to pretend this is a completely new running of the game, so nothing about number 9 is going to change what happens in number 10. So in number 10, we want to get tails. What's the probability of getting tails? We know that anything on a coin is going to be 1/2. How about a multiple of 3? So we need to roll the 12-sided die and get a multiple of 3. We know our denominator is going to be 12 because the 12-sided die is numbered 1 through 12. How many of those numbers, 1 through 12, are multiples of 3? 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. And 3 times 4 is 12. So of the numbers 1 through 12, 4 of them, 3, 6, 9, and 12, are a multiple of 3. So we're going to put a 4 on top because we have 4 winning numbers. And then we're going to put our multiplication symbol. We'll put it a little farther over here for a reason we'll talk about in a minute. Lastly, we win on the spinner if we get green or white. So first thing we want to do is we want to make sure we know what our denominator is. How many different total possible results are there on the spinner? There are 6. And of them, how many win for us? Well, this time around, it's 2. We win if we get a green or a white. So we're going to put a 2 on top. Now, before we do our multiplication, let's look at the possibility of simplifying. 1/2 cannot be simplified. What about 4 twelfths? 4 and 12 can both be divided by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. So 4 twelfths simplifies to 1/3. What about 2 sixths? Both of those can be divided by 2. 2 divided by 2 is 1, and 6 divided by 2 is 3. So that also simplifies to 1/3. So what is our final answer? Now that we've simplified, we can multiply. Across the top now we have 1 times 1 times 1. That of course is 1. And across the bottom we have 2 times 3 times 3. 2 times 3 is 6. Times 3 is 18. But wait, the problem says we want the answer as a percentage. How do we calculate that? We're going to take 1 over 18, and I'm going to rewrite this slightly here. We're going to take 1 over 18, which is our probability fraction, and we're going to set it equal to an unknown number over 100. So we're setting up a proportion where our probability fraction is here, and the other side has no numerator yet and has 100 as the denominator, because 100 as a denominator is what a percentage is. Then we're going to use our proportion setup to multiply our diagonal. 100 times 1 is 100. And then you're going to divide by the number you haven't used yet. 100 divided by 18. What does that give us? 100 divided by 18. Remember, you have a calculator built into your school laptop. 100 divided by 18 is 5.5 repeating. So the answer that goes up here is 5.5. The line over that second 5 means repeating. So the possibility of a percentage, or the probability as a percentage, is 5.5%. Oh, I just realized I didn't put those answers up here. So 5.5%. Let me make sure I have the other one put up here. The answer to number 9 was 5 out of 144. Okay. Let's move on finally to number 11. What are the odds of flipping a heads, flipping a factor of 12, and then spinning a blue? We want this as a ratio in simplest form because we're doing odds. Our starting process is going to be exactly the same as it has been for number 9 and number 10. In fact, this is always going to be your starting process. Put down number 11 here. we're going to figure out each individual probability in the sequence, simplify if we can, and then multiply together. We know the probability of getting heads is 1 over 2. Then we want a factor of 12 on a 12-sided die. What are the factors of 12? Well, you can do 1 times 12. You could get 2 times 6. Or you could multiply 3 times 4. Those are all the factors of 12. So we would have 6 possible winning numbers. We win if we get any of these 6 numbers. And there are 12 total possible results on a 12-sided die. And then we win if we get blue. There are 6 possible ways that that spinner can go: red, blue, black, green, white, yellow. And of them, 1 is blue. So our probability of spinning blue is 1 over 6. Let's see if we can simplify. 6 over 12, both of those can be divided by 6. 6 divided by 6 is 1. 12 divided by 6 is 2. So we simplify 6/12 down to 1/2. 1/2 and 1/6 cannot be simplified any further because they have a 1 in their numerators. All right, once we've simplified, we can multiply. Across the top, we have 1 times 1 times 1. That's 1. And across the bottom, we have 2 times 2 is 4, times 6 is 24. So our probability fraction is 1/24. But we want this as odds. Remember, odds are losers on the left, colon, winners on the right. So how many ways in our probability fraction are there to win? That's going to be our numerator, and that's a 1. So a 1 goes on the right, where the winners go. Put our 2 dots. How many of the results of our probability fraction are losers? Well, there are 24 possible results. 1 of them is a winner. All the rest are losers. What's 24 minus 1? That would be 23 ways to lose. So our odds of the exact sequence, heads, factor of 12, blue, are 23-1. There will be a set of 6 questions very similar to this setup on your homework in just a few minutes. As always, stay home, wash your hands, be safe, and I hope to see you all very soon. Bye.